Hey everyone, it's Anthony, and today we're going to do something a little different. We're going to cover something I was exploring, which is using Stumpy. So Stumpy is a library that lets you find the most similar subseries in a long time series. And I found this library while listening to his podcast, Data Skeptic, and put a link right here. So in order to show how Stumpy works, we're going to try to analyze some time series data. We're going to first try some stocks and then try to analyze some temperature data. So let's get started. Okay, so you can see I've imported a bunch of libraries. Then I used this Y Finance library in order to pull up some financial information for Caterpillar. So I called the library using the yf.ticker, get cat, and then I can see information about the company. Next, I want to actually get some stock data from it, which we'll do right now. Okay, so we've used this function history here in order to specify a start date and end date of the stock prices that we want. Then we can figure out what type of data this is. We'll just do type. You see that it's a pandas data frame. I want to look at the columns. So there's a few ways I could do this. I could go x.head, or I could do what I showed here, where it's say just x.columns. X.head is nice because I can also see additional information. When I first got this data, I wanted to plot it using this built-in function of pandas, or basically it's going to call matplotlib. And in order to do that, I need to specify an x-axis. The x values that I want to use are actually the date, but that's the index. So I made a new column, x date, and I just specified the x.index as that value. Then after I have that, I'm able to plot my time series values over time. So the x values are the date again, and then the y I said was the opening value. And there we go. So we can see the opening value for Caterpillar stock. Now let's move on to actually using Stumpy. Okay, so I've run Stumpy now. So what it's going to do is look through my opening values, take subsequences that are this length, and then find the most similar subsequence for every single subsequence. And to understand what the output is, we can take a look at the documentation. So you can see it's a convenience wrapper around a number, which will make it run a lot faster. For the output, it says the first column consists of the matrix profile, the second column consists of the matrix profile index. So then if we take a look at the documentation to understand what that is, if we take a look at the documentation on the website, here we're basically finding the Euclidean distance between these two subsequences. The nearest neighbor is referred to as the matrix profile, so that was the first column, and then the index is going to be the second column. So back to our code. Right here. So the first column consists of the matrix profile, the second consists of the matrix profile index. So what we want to do then, or find how it would be sorted, this is going to tell us the index where it would be the lowest, the motif IDX. And then if I take the second column, that's going to tell me the index of its nearest neighbor. And that's how we get these two values. I can see that the array size is going to be 507 by 4, and so it's going to be a numpy int array. Interestingly, it's the type of array was of object, so I used as type to convert to a float, and then I wanted to plot it just to kind of see what's going on. And this is what it looks like. I'm going to use the tutorial on the Stumpy website to make a nice plot. I'm just going to basically just paste some code. Okay, so I basically just took the exact code from the Stumpy website, and which is shown here, and just modified it a little bit. And what this is saying is that these two regions are the most similar of all the values in this time series data, which is a little bit tricky to see based off this plot. So let's make some additional plots to see better what's going on. Okay, you can see I've taken the numpy, I've taken the data frame as a 2 numpy. Let's get my values. Now I'm making another plot here where I forgot to get the nearest neighbor. I had to convert it to N32 because I want to use it as an index. So then I got my Y1 values, which are just the first subseries values, and then the Y2 are the second subseries values, which would be here. And then I plotted them on 2 different subplots in this figure. And you can see they look kind of similar, which is what we expect. Okay, if I make another plot here where I subtract off the mean of each of these, so basically kind of normalizing it, and then I plot them together, you can see that these 2 time series are actually quite similar, which is really what we were after from the start. So it doesn't matter that they're separated by a large, like the magnitude is different, it's more of like the shape that matters. So this can be a helpful tool for finding within a time series the values that are changing in a similar way, although their magnitude might be quite a bit different. Right, so next we're going to try this on weather. So I'm going to get some weather values using this tutorial I found, and then which is basically using this library, World Weather Online. So let's go ahead and get going. Okay, so first, this particular API requires an API key. It's a free API for 30 days. So I signed up for the 30-day trial. I got my API key. I put it into a file called API-key.txt, and then I'm writing a function which is just going to read that key and get it for me. And also I made sure that in my Git repository that I added a git ignore for this particular file because I don't want to commit it to version control, which would generally be bad. So this allows me to automatically get my API key without having to show it here in the Jupyter Notebook. So let's continue and actually get our values. Okay, so I've written the code to call the API, and I'm going to get the weather for Albuquerque from January 1st, 2018 to February 2nd, 2022. One important thing to note here is that I want to make sure I actually save this data with the export CSV. That way I only have to call this one time, and I don't lose my data if I have to restart my notebook again. Okay, so I am using pandas read CSV to actually read the saved CSV file, and I'm going to call head just to see what's going on, see what kind of values we have available. And you can see there's a lot of columns actually. And we're just going to pick one of them in order to do our time series analysis. So likely something that would be interesting would be the temperature, so let's try that. Okay, so I'm using Matplotlib again in order to get the max temperature for every day. And I'm converting it to a float. Then I'm plotting it. I didn't want to include the x-axis as the time values because I'll just make it run slow, or I could set up the ticks that I want. However, that'd just be a little more work, so I'm not going to worry about it. I know this is January 1st, and you can see pretty clearly the cycle, the seasons of the year going forward. So let's try applying Stumpy to this time series data. Okay, so the first thing you'll notice is that the second time I ran Stumpy, it was significantly faster, which is good because the first time it took a while. Right, so let's make a plot like we did the first time, trying to see the most similar regions. So I've plotted my time series data again for this data set, and you can see where it's most similar. However, they're right next to each other, which is maybe not what we want. So instead, let's go ahead and do what we did last time, which was to just plot the two right next to each other, and then we'll see how similar they actually are, and then also we'll increase the time that we want to be similar, or the substrings. Okay, so I plotted the two time series values side by side to see how similar they look, and they do look pretty similar. Again, they're offset a little bit. If I plot them by subtracting the mean, you can see that they actually look quite similar, which is interesting. No doubt this is why it was flagged as being the most similar. Let's increase the substring size that we're interested in finding and just see what happens. So right now I have it as 30. Let's change it, let's say, to 50. And again, you can see it's actually pretty close to each other, or right next to each other. Just maybe a little surprising again. However, I would agree that those look quite similar. I was hoping for it to be something a little bit bigger. Let's try changing it to like 7. So 7 would make sense because we asked for data every day. So this is maybe a little more interesting that these two locations have nearly the same week as far as their temperatures, which we can see there. Again, was maybe not what exactly I was expecting. Let's change it to be like 2 months. Okay, so this is more what I was expecting, where we have different parts of a year that are relatively similar. So the first one is here, the second one is later on, so this will be more recent. Likely this is 2021, at the end of 2021. So maybe in December. You can see that I have some similar pattern to back here. If I plot the two, they do look kind of similar, and you can see they're both going down in a similar trend, which is interesting. So Stumpy is pretty interesting. You can definitely use it to quickly find data within a time series that's similar to itself, and this could be helpful for a lot of applications. And I hope you found this tutorial helpful.